Welcome everyone. I'll be taking up Mathematics 4, code KAS 302/402. The topic for today's presentation is Statistical Techniques 2. Myself Dr. Ruchira Goel from Department of Applied Science and Humanities, Ajay Kumar Garg Engineering College, Ghaziabad. So the contents which I'll be taking today are some introduction based on this concept of probability, then addition and multiplication law of probability, and conditional probability and Bayes' theorem. So coming to the theory of probability. Now what is probability? Probability is a concept which measures the degree of uncertainty of the occurrence of events. Now there is a uncertainty defined in every event which is being conducted. So how to accept that event, how to measure that event, we will use probability for that measurement. Now first of all, we will define certain terms which are used frequently. So the first one is trial and event. Now let us understand what is a trial and what is an event. So let an experiment be repeated under the same conditions and it results in any one of the several possible outcomes. Then the experiment is called a trial. So for example, we have a coin and we are tossing it. So repeated tossing of the coin is known as a trial. And the possible outcomes are called events. So when we toss a coin, then in that situation, the coin will result into turning of either a head or a tail. So this becomes an event. So there is a difference between trial. Trial is when we are performing an experiment, and event is the outcome of that experiment is known as an event. So event is outcome. For example, we can take another example. Suppose we have a die. So when we toss a dice, then tossing of the dice is the trial, and this is trial. And when we have certain outcome, for example, we get 1 or 2 or 3 up to any 6. There are 6 faces of the dice. So these are the events, because we are getting these values after. These are the outcomes when we toss a dice. So this is the definition of trial and event. Now coming to the type of event. So first one is exhaustive event. Now what is an exhaustive event? The total number of all possible outcomes in any trial is known as exhaustive events. For example, when we are tossing a coin, we can get either a head or a tail. So getting a head or a tail will become the outcome. There are two outcomes. These constitute an exhaustive event, because no other outcome is possible. Because a coin is two-sided, it can have either a head or a tail. So no other outcome is possible. Similarly, in the case of a dice, we have 6 possible outcomes, getting 1, 2, 3, any number till up to 6. So they are all exhaustive events. They are all exhaustive events in case of a dice. Now mutually exclusive events. So mutually exclusive events means the events are said to be mutually exclusive if happening of any one out of all the events rules out. Rules out means there is no possibility of occurring of any other event. That means the happening of one of them rules out the happening of all others. Then this is known as mutually exclusive event. For example, when we toss a coin, then we get either a head or a tail, but we cannot get both. So no possibility of getting both of them together. So these are mutually exclusive events. So events were exhaustive also, and they are mutually exclusive also. Similarly, if in case of a dice, we will get either 1, either 2, either 3, 4, 5 or 6. So they are also mutually exclusive. So coming to another definition of event, that is equally likely event. Now events are said to be equally likely if there is no reason to expect any one in preference to any other. So, if there is no possibility that one of them can occur before the other one, we cannot expect that, then they are equally likely. For example, when we draw a card from a well shuffled pack, we may get any card out of 52 cards. We can get any card because the pack is well shuffled, so there is no possibility. If the case is like if we are having doing some cheating, in that case situation we are not shuffling the pack, then the event won't be equally likely. But since we are considering a well shuffled pack, so in that situation it becomes equally likely that we can get either of the cards. So the possibility of drawing a certain card, for example, we are drawing a ace of spade, then the drawing of spade and drawing of ace of heart will be equally likely. So the probability will be 1 by 52 for each of them. Now, if we come to the classical definition of probability, the definition is like this: if there are n equally likely, mutually exclusive and exhaustive events, so all these three conditions, if they are fulfilled from an experiment and m of these are favorable, so then the probability, favorable means we are looking that whatever we want to see, we want to study, then that is available, the situation is applicable. For example, if we want to draw, we want to get a head, then we must be in a situation to get a head. So that is a favorable case of getting a head when we are tossing a coin. Similarly, if we want 4 or 5 on our dice on the upward side, then getting 4 or 5 on the dice on the upward side will become a favorable case. So then the probability of happening of the event is given by m upon n. M is number of favorable cases, n is your total number of equally likely, mutually exclusive and exhaustive events. So this will be the probability of the happening of the favorable case. Similarly, if we change our case, then the probability will change according to the study of the event we are doing. Now, there are two laws of probability, one is addition and another is multiplication. So, for addition law of probability, we have two cases, one is for mutually exclusive events and another is for non-mutually exclusive events. So, let us consider them one at a time. So, for mutually exclusive events, if we consider P1, P2 and so on up to Pn, the probabilities, separate probabilities of mutually exclusive events. So there are n events we are considering and their probabilities we are taking as P1, P2 up to Pn. Then the total probability P of any of these events to happen will be given by the sum of the probabilities, because these events are mutually exclusive. So we will add the probabilities of the occurrence of any of them. P1 is the probability of the occurrence of first event, P2 is the probability of occurrence of second event, and till we reach the nth event, whatever the probability is, we will add all the probabilities and that combined value will be the occurrence of the probability of any of the events. So this is the case for mutually exclusive events. Now coming to non-mutually exclusive events. So for non-mutually exclusive events, if two events, say A and B, are not mutually exclusive, please understand this is for not mutually exclusive. For mutually exclusive, we are adding all the probabilities separately, which we have taken for each of the event. Now for not mutually exclusive, what we will do, the probability of the event that either A or B occur is given by the formula probability A union B is equal to probability A plus probability B minus probability A intersection B. Actually, what we are doing, we are adding the probability of occurrence of A and occurrence of B and the combined probability that both of them can occur simultaneously. We are, since the events are not mutually exclusive, we are subtracting that probability from the total sum of the exclusive probabilities. So this is quite logical. Hence, this may also be represented in this manner: probability A or B equal to probability A plus probability B minus probability A intersection A and B. This intersection denotes and union denotes or. Now let us consider consider an example, so we will understand it better. So suppose we have an urn. Urn means you can consider it as a bag or something, so, or a pot. So suppose that urn contains 10 black and 10 white balls. So we have this urn and it has black and white, both are 10 in number. So total number of balls combined together will become 20. So we have to find the probability of drawing 2 balls. So if we want to draw 2 balls, first of all, out of 20 we have to select 2. So 20 C2 is the total number of outcomes which we have to consider. Now these 2 balls are of the same color. So in case they are of the black color, that will be accounted from this particular side. So this will be, you can say 10 C2, because out of 10 you will be selecting 2. And similarly for white, you will have again 10 C2. So you have 10 C2 divided by 20 C2. So this is probability of black and this is probability of white. Now since these are mutually exclusive, so that's why drawing of 2 balls of the same color, we will either, it will be both black or it will be both white, but it cannot be occurring simultaneously because the balls are either white or black. So we will have 10 C2 divided by 20 C2, the probability of having a black ball, and 10 C2 divided by 20 C2, the probability of having a white ball. So the total probability becomes 2 times 10 C2 divided by 20 C2, and we will calculate this value 10 into 9 upon 2 into 1 and 20 into 19 upon 2 into 1, which comes out to be 9 upon 19. So this is the probability of getting the same color ball, either black or white. Coming up to the next law of probability, that is multiplication law of probability. So for independent events, this law is applicable. This is not for mutually exclusive, this is for independent events. Now, if there are 2 independent events, the respective probabilities of which are known, then the probability that both will happen is the product of the probabilities of their happening respectively. That means probability A and B together will be equal to probability A into probability B. So now comes a query: what is the difference between mutually exclusive and independent? Mutually exclusive is when we have 2 events which cannot occur simultaneously, but independent is when the 2 events are occurring independent of each other. So that is independent event. So in that situation, we multiply the probability value, and in the first situation, in the previous situation, we will add the values. Let us consider an example of independent event. A problem of statistics is given to 3 students. There are 3 students, A, B and C. whose chances of solving are 1 by 2, 3 by 4 and 1 by 4 respectively. Since the students are different, all three are different, it is not the same student. So obviously, if one is solving, one of the students, suppose A is solving, then that solution will be independent of what B is doing. So B can solve the problem at the same time. And similarly, C can also solve the problem at the same time. So he is independent of the first two, A and B. So we have to find the probability that the problem will be solved. The problem will be solved. Now, since the solution all three are doing separately, so this is an independent event. So we are given 1 by 2, 3 by 4 and 1 by 4 as the probabilities of A, B, C solving the problem. Now, the probability of A, B and C not solving the problem are obviously it will be 1 minus 1 by 2, since the probability value always lies between, for any event lies between 0 and 1. So 1 by 2 is the probability of solving. So 1 minus 1 by 2 will be the probability of not solving by A. This will be the probability of not solving by B, and this will be the probability of not solving by the student C. So 1 minus 1 by 2, 1 minus 3 by 4, 1 minus 1 by 4. These are the three probabilities which turns out to be 1 by 2, 1 by 4 and 3 by 4 respectively. Now the probability that problem is not solved by any of them will be, since the event is independent, so it will be multiplied. So 1 by 2 into 1 by 4 into 3 by 4, which comes out to be 3 upon 32. So this is the probability that none of the students will solve the problem. Hence, the problem will be solved by either of them will be 1 minus 3 upon 32. That means the total probability of solution will be 1. So minus none of them can solve will be 3 upon 32. So this comes out to be 29 upon 32. It means that either A or B or C will at least solve the problem which is given. So in this way our work will be done, and this event was independent. Now coming to conditional probability. Conditional probability. So conditional probability is the probability of the happening of an event A when another event B is happening, and when another event B is already known to have happened, means B has already occurred and A is going to occur, is called conditional probability. So this is denoted by the symbol probability A such that B has already occurred. So the event which occurs is written in the denominator side, and the event which is going to occur will be in the numerator part. So this is also denoted by small p bracket A by B. That means probability of A given B has occurred. This is equal to probability A intersection B divided by probability B. Or we can also write this in the manner, we can take this over this side, and probability A intersection B is equal to probability A by B into probability B. So this is the probability of the conditional probability. This, for example, suppose we have an urn, and in the urn we are having suppose black and red ball. So if we want, suppose that we want to find the probability of getting a red ball provided the black ball has been drawn. Then to find this value we will require probability of red ball and black ball divided by probability of the black ball, because this drawing of the red ball depends that probability of the drawing of the black ball has already, the event of drawing of the black ball has already been done. So now the total number of balls which was earlier there has been reduced, and from the remaining balls we have to draw the red ball. If instead we replenish the ball back which we have drawn, then that won't be a conditional probability, that will be counted as independent event. So in this situation we will use this formula. So for independent event, therefore it is written that for independent event, if the events A and B are independent, then probability A given B is equal to probability of the event of occurrence of A, because then B has no significance whether it has happened or whatever. We have taken something out, we have replenished back, and in that situation the probability of it is treated as getting the event done in the first instance only. That means getting a red ball provided the initial nothing has been done with the given balls or the urn. Now coming to the most important theorem, that is Bayes' theorem. So this theorem provides an insight into when we have n number of events which are mutually exclusive and exhaustive, then how to calculate the probability. So this is a generalized way and it makes our task much easier. So if E1, E2, En are mutually exclusive and exhaustive events with probability of each event not equal to 0. We must understand that we cannot consider the probability of any of the events to be 0 of a random experiment. Then for any arbitrary event A of the sample space of above experiment with probability of A, obviously it should be more than 0, it should not be 0, but it has to be obviously less than 1. We have probability of occurrence of any event EI given A has already occurred equal to probability EI into probability A given EI divided by sigma I equal to 1 to n probability EI into probability A given EI. This summation means all the n values will be considered. That means this formula can also be written as probability EI, probability A given EI divided by sigma I equal to 1 to n, sorry, this is not required. So this will be probability E1, probability A given E1 plus probability E2, probability A given E2, and this summation will continue till probability En, probability A given En. Now let us consider this theorem with an example. So suppose we have a bag, we have two bags, bag 1 and bag 2, and first bag contains 3 white and 4 red balls. So we have this bag, it has 3 white and 4 red balls. This is bag number 1. We have another bag. So this has 5 white and 6 red balls. This is bag number 2. So one of the balls is drawn at random from one of the bags and it is found to be white. So this ball is white is my event A, for which I am going to find the probability that the ball is drawn from first bag. So ball is drawn from first bag, this event is given by E1, denoted by E1, and E2 is the ball is drawn from the bag 2, the second bag. So we have to find probability of the ball being white provided it is from the first bag. That means we have to find probability of E1 given that the ball is white, it is drawn from the first bag. So by Bayes' theorem we have this formula, probability E1 given A equal to probability E1 into probability A given E1 divided by probability E1 into probability A given E1 plus probability E2 into probability A given E2. Since two bags are equally likely to be picked, either we can pick the first bag or the second bag, hence the probability of both of them to pick up is 1/2. The probability that the ball is white provided from the first bag is 3/7 because it has 3 balls which are white in the first bag. Total number of balls in this bag comes out to be 7. Whereas in the second bag the total number of balls is 11. So white are 5. So it will be 5/11. Therefore, from equation number 1, if we substitute the values, we get probability of E1, that means getting the ball from the first bag, and that too a white ball, is 1/2 into 3/7 divided by 1/2 into 3/7 plus 1/2 into 5/11, which comes out to be 33/68. Let us consider one more example. So, the probability that a civilian can hit a target is 2/5. This is 2/5. And the probability that an army officer can hit the same target is 3/5. So, a civilian can fire 8 shots in a given time, and army officer can fire 10 shots. Now, if they fire together, then what is the probability that civilian shoots the target? So, here the occurrence of the event is the target is hit, and that too by a civilian. So, the civilian can hit a target is denoted by E1, and an army officer can hit the target is denoted by E2. So, we have to find the probability E1 given that the target is hit, that means a civilian can hit the target. So, by Bayes' theorem, probability E1 given A will be equal to probability E1 into probability A given E1 divided by probability E1 into probability A given E1 plus probability E2 into probability A given E2. Now, first of all, we have to decide what are the probabilities A given E1 and A given E2. So, probability E1 is already given in the question itself, that is 2/5, that the target is hit by a civilian, and probability E2 that the target is hit by a army officer is given to be 3/5. Therefore, probability A given E1 becomes 8/18 because total 8 times a civilian can hit. So, civilian can have 8 shots and army officer can have 10 shots. So, total number of shots comes out to be So, total comes out to be 18 shots. So, that is why 8/18 is the probability of a civilian can hit a target, and 10/18 is the probability that a army officer, the shot is by the army officer. Hence, we from equation number 1, that is from the Bayes' theorem, probability of the civilian hitting a target will be 2/5 into 8/18 divided by 2/5 into 8/18 plus 3/5 into 10/18, which comes out to be 8/23. So, this probability is a very interesting topic which is used in many branches of engineering, in machine learning, in data structures, in logistics, everywhere. Hence, it is very important to understand this concept thoroughly. I hope I can make it clear to you. Thank you.